Tell us about Rate Transient Analysis in your arm waving paper.
Yeah. Well, when anybody interprets data, there's always a little bit of arm waving. So what RTA is, as I mentioned before, it's Advanced Production Data Analysis and Modeling. And what that really means is that the data that is the feedstock for the science that operators use to inform them about field development decisions and coming up with more reliable production forecasts for the purposes of reserves, which of course influences their stock price, is the data is flowing pressures from a wellhead, typically surface pressures, tubing or casing pressure, because you got to know like how the well is being operated. Is it at a high percentage drawdown or a low percentage drawdown, and you're really trying to get those rates up as high as they can go, or are you choked back? So a lot of the information that the reservoir is trying to communicate at surface is contained in those pressures. So at a we'll call it really basic understanding of the geology and that production data, and from that, you can build straight line analysis techniques, XY plots, this against that, draw a straight line through the data. Engineers like straight lines. So you manipulate time functions and, in order to turn the data straight so you can learn something about what's going on. And those things that you learn are properties that you may have heard about, like the permeability, which is a transport characteristic of the rock, like how much does that oil and gas flow in the ground? How easily or not easily does it flow? If all you're looking at is right off a wellhead, you can watch the show, Landman, as we probably all have, and you can say, look at that's up to 150 barrels per day or whatever, like we're making money. Like, that's useful, and that'll tell you that, hey, we should probably drill more wells here or whatever. But what RTA can give you is a deeper understanding of what's driving that performance. Like what specifically in the reservoir is causing that well to hit that rate. It's what is often referred to as reservoir characterization. And that's when you start to understand and sort of decouple the contributions from your frac, from your stimulation on the completion side, and what God gave you in the ground, for whatever that expression is, the permeability, the pressures, the porosity, all the things that were there to begin with.
Gotcha.
Now you can do more detail than RTA. RTA is just what I call a practical sort of, and I said pragmatic way of doing it, because you can do it fairly quickly. But if you really want to go nuts, you probably heard about production simulation and companies like CMG and, SLB has got their suite of tools like Kinetics and, everything else. Like, these are the guys that are handcuffed to their computers and they're just doing history matching routines through that production data. And they're just spending an enormous amount of time integrating with other disparate sources of oil field data, other sciences, and doing these holistic integrated reservoir studies. Those things can take months. And that's the Cadillac. Like, if you want to go all the way, RTA is sort of, it's a middle of the road sort of amount of work for the deliverables that you get. And for a lot of operators, especially those mid-sized ones with lots of wells to analyze, it's fit for purpose. It's got a nice home there of maybe you can do RTA 2, 3, 4 wells a day. So if you got 100 wells, do the math. So the idea here is that RTA is creating models that are physical models, but they're functional models. They're useful models. And you guys have probably heard the expression, all models are wrong, some models are useful. Mm-hmm. Well, and for 15 years running this stupid thing, and I'm essentially a man who owns a hammer, and I just hammer things every day. I know what it can do, and I know what it can't. And a lot of people think it can't do things that it absolutely can't do. And sometimes these simple models do provide great insights. But if I was going to use an RTA model for well spacing optimization in not a green field, but a well-developed field where you're doing infill wells, and geomechanics are a really big deal. You've heard about pressure sinks, where a child well or an infill well does its frac and it chases that pressure sink from the old parent well that's been on production. Yeah. So you don't, the distribution of your fracture geometry isn't what you planned it to be. Mm-hmm. And there's all these other complexities from depletion and geomechanics. Well, is RTA good for that? Not as a predicting tool. As a post-mortem tool, sure. Look back, no problem. An autopsy, terrific. As a predictive tool in that environment, not very reliable.
Data in hand, we rock the bytes and we'll take a stand. Calculators flashing like a disco